Yeah, I'm a philosopher working with Jakob Hovi in the philosophy department. My thesis, my PhD thesis is on IIT, like the philosophical aspects of IIT. Actually, the idea was to kind of integrate in a way IIT with the free energy principle, this type of kind of Bristolian story. And actually, these questions kind of came up because I was trying to link IIT the free energy principle through this notion of matching, and then going backwards, I got into this idea of correspondence between qualia shape and experiences.
Okay, and maybe let me also ask Steve, if you are there, do you want to show your face and then maybe introduce yourself? He was actually here once when he visited us, and yeah, please, Steve. We can't hear you. Maybe you are muted. Or is it related to the speaker here?
He's trying to speak, he's still on mute.
Or is this actually audible?
It's him on mute. That's the symbol.
Yeah, Steve, you are muted.
How's that?
Yes,
good.
yeah, good.
Okay. Hi, I'm Steve. I'm working in Japan. My interest is in category theory, approaches to cognitive science in general. And recently, now I and myself and Hayato have been getting together on this issue about consciousness by category theory approach. So looking forward to hearing about your latest work.
Yeah, so he's the go-to person for me when it comes to category theory properly. So, okay, so let's get started from the Niccolo's question. This is a bit too small, so I'll just split it into several pages. Okay, go ahead, Niccolo.
Yes, so like the first is, I guess, this idea that it's based on the final scope of the project, at least as far as I understand it, which is the fact that we can actually study the informational level of another subject, and that we don't know the consciousness of, to infer like the state of consciousness of that subject. Right? I think there are two assumptions, right, behind this project. One is that there must be some sort of robustness, like between different subjects, in a certain sense that what the information that I gather from one subject, the information and experience type of relation on one subject is relevant to other subjects, right? But also,
but before moving on, what do you mean by robustness here exactly?
The idea that the type of information that like you gather if you study my brain, okay, and the relation between the information level and the experience in my case can be applicable to other cases.
So right? It's like a correspondence, or there may be some kind of link. That's what you mean by robustness.
Yeah.
But robustness usually means something different, I feel. But okay, I understand what you mean.
Some sort of regularity.
Okay.
That's
okay. Structural correspondence or something like that.
Yeah, but across different subjects.
Yeah, okay, that's fine. Then, and the intrasubjective.
And then the same idea, but within the same subject, like across time.
Across time, that's the intra, all right?
Yeah, something like that. Right?
Maybe I should just say that mix, by that what he means is some kind of structure proposed in IIT. Something that you extract from the structure and the activity states of the neurons in the brain to qualia shape, so-called. And it means maximally irreducible conceptual structure. It's impossible to read. Okay.
So can we say the robustness or can be exchanged to variability? Because within psychology, if you are talking about concepts, like if you want to measure something like stress or something, you would describe the measure how reliably measure something, and you have intersubjective reliability and within subject reliability.
Okay.
I don't know if
Okay.
that's the same that you are talking about.
I think so. I think
Sounds
so, right?
similar to me.
Yeah, that's the type of I don't know if it can be called a measure like in this sense, but like the information that you have like coming from one subject is reliable, right? When you transfer that information to other subjects.
Yes, and you're kind of examining the same concept across subjects as well.
Right.
Okay.
That's what they
All right then.
Then I guess the first problem is that in the context of IIT, that's kind of, it's difficult to see how we can justify this sort of intersubjective reliability there.
But before further going, maybe I should just make it clear that according to IIT, or if IIT is correct, then these two things of the statement, similar mix should correspond to similar experiences across subject and within subject, is something that is a highly reasonable statement to make, I would say. But IIT itself doesn't say that, right? I mean, this is something that we are kind of, trying to test as a sort of a test of the IIT validity, or, unless it holds, IIT is quite, useless. So that's our assumption, but not the IIT itself's assumption, I would say.
Okay, that's the question. Like, how do we justify the idea that we are studying structural correspondence between different subjects in IIT?
Yeah.
Like, why do we assume that it holds across different subjects? That's exactly my question.
Okay.
It's why do we assume that?
Okay.
And perhaps the hypothesis that I was just throwing there just to work with is perhaps it's this notion of matching, right? Because we are kind of exposed to the same like regularities, equal regularities, the same environment, and the notion of matching is this idea that the internal structure should match the external structures, right? So since the external structure are the same for us, that kind of makes sense.
Probably somebody needs to explain what matching means in IIT, or did you guys read the paper?
Not
Matching?
yet.
Not yet? Or do you want to explain what the matching means in IIT?
The matching, as far as I understand, is that basically the causal structures that constitute the maximum reducible concept of structure, the Fourier shape, right? Are completely intrinsic and internal, right? The idea is how do we justify the fact that we assume that the different people have similar structure, internal intrinsic structures, and the idea of matching helps with this. It says that the internal structures and informational structures have to match the external informational structure of the environment, the statistical regularities of the environment, right? That's why, as a hypothesis, I don't know, we can perhaps work on the idea that because of this matching, right, because the environment is the same, like for different subjects, and different subjects have to match the same environment, and that's why, like indirectly, the internal structure of each individual subject is similar. There is a similar correspondence, right? Similar correspondence.
Do you mean by controlling for, like just putting people under the same conditions by matching the external environment?
Yeah, I mean, that's something that should happen like even before any type of experimental approach, right?
Yes, and by matching internal informational structure with the external environment structure, what do you mean by that? I'm not sure about what you mean by external structure here.
I don't know if there is like a causal relation in the external world. Like that's an information. That's a sort of regularity that happens in the world independently of a subject, right?
So
and the subject recapitulates that in its own brain.
this is probably something that is already kind of related to our project in a sense, and I'm going to explain on the whiteboard. Can you? So this is the reason why I thought that Yota's project may be relevant to actually present here. It's a very simple example that Yota is working hard. It's a system that consists of 2 neurons. You can't have anything simpler, right? And then you have a stimulus that corresponding to the light input that drives these 2 neurons. Okay, and then it has some kind of self-connection, and then there's some kind of lateral connection as well. So this is a minimum generating kind of structure. Okay, and then here what we are talking about is this matching of this environmental pattern here. And what in this particular project what we are thinking is that there can be 4 different patterns, right, for this system. It could be either on or off or on and off. And let's imagine that this one has some kind of direction of the visibility or something like that. Then if there is some kind of dark and the right kind of environment, and then this 2 neuron system is actually looking at this wall in this way, then it's likely that after this you are likely to see either this or that, but not directly to here, right? Unless you make a sudden jump. As long as you're making some kind of smooth motion, this transits to that and so on. So if this kind of system develops and then makes some kind of causal structure, eventually it will generate some kind of conceptual or conscious experience which seems to distinguish between all these 4 things, pattern A, B, C, D, but at the same time, it will probably form some kind of similarity relationship between this to this and this to that, but not to this. And also, most likely, this and this are kind of similar, right? At least for us, it's flipping the sign. So this is also potentially, similar. Something like this should be extended in a much more complicated way. Of course, this is just a 2 pixel, right? And then we need to think about sound and also, touch and emotion and all sorts of these kind of, things has to be captured by the structure of these 2 things, internal, IIT structure in the end. And what Yota is trying to do eventually is that looking at these neurons, internal structure only by looking at this. And then if this is, in the state of off or on or off on or on, does it actually make a prediction about, external? Really likely, and possess some kind of similarity structure like this, as we, hope. But that depends on, strengths of this input and also strengths of this recurrent connection and lateral connection. And this is a very complicated, simulation, but we are getting handles on it.
Niccolo, just to check with you, there's 2 potential matching things that I see, and I'm not sure which out of either of them or both there is that you're referring to. So there's the matching between physical stimuli out in the world, in some sense, and like information structures that are presumably in the brain. And then there's trying to match those information structures to the actual experiences that a conscious experiencer might have. Does the match, which of either of those does matching refer to?
If I understand IIT correctly, is the physical causal structure.
Okay.
The physical one, if I understand IIT correctly.
So, but that's a good question. So if there is another guy with, let's say, 3 neuron structure or something like that, let's say 2 neuron and then plus another one back end, and if these 2 guys are experiencing the same world, right, then this one, because of the third neuron, it has a much more richer kind of structure, but this one can have subset of the mix that mimics this one. And that's probably the situation where we can start to compare the experience of this 2 neuron system consciousness and 3 neuron system consciousness. You see what I'm saying?
Assuming that their experience of them are similar.
Yeah.
Okay.
Assuming.
Okay.
But my idea of category theory and also IIT is that eventually we have to compare this completely different structure, right? 2 neuron versus 3 neuron, but the subset of that is similar. And that's something that we need to be able to compare. Like, I believe that even if I encounter somebody who, let's say, has never had any sound experience from the beginning, or maybe half the brain cut or whatever, part of our experience with my experience with that person is likely to be shared. Even though as a whole, it's not the same. But how do we actually compare that is a huge, completely big mystery. But I think we can start to work it out with your simulation and so on. 2 neuron system, 3 neuron system, and so on. But this is importantly, matched through the environmental structure, not the exact 1.1 object to experience kind of mapping. That's why structure mapping is important. Make sense? More or less.
I think so, yeah.
Okay.
I guess the doubt that I had is that if we follow like IIT, like the consciousness in itself is like a completely intrinsic story, right?
Yeah.
So, so would you be happy to say that the 2 neurons in that simulation actually process the information, or not? Or they just
in the sense of IIT, yes. But the processing of the information has a lot of meaning, and many people, if we start to talk about that itself is going to be like 1 hour discussion. So maybe we can talk about it, but not now, and then make a progress. Or if somebody wants to answer whether this is processing information or not, it does. Information processing in IIT, just very briefly, means that something is causally affecting other things, and also it's affected by other things. But many people just think about information processing in different ways. You can just think about it as a causal interaction. That's much better way of interpreting information processing in IIT sense.
Right. So is the neuron causal interacting with the light, or just with the other neuron?
No. This one doesn't have any kind of motor, sensor or anything like that, right? This one is causally interacting with itself.
Right. Okay.
But influenced by the environment.
That's what. Yeah. That's what. So it is insulated, kind of. Right. The 2 neurons are completely insulated.
No, but it has a background condition is there.
Okay. That's.
Okay. All right. So this one is more or less fine then. Which I should. Do you see this to be shared or not? No. Where's the sharing thing? Okay. So now everybody can see. All right. So then this second part is fine, right? Then.
Yeah.
Okay, let's go to the third one. But this is again. So, all right. Go ahead.
Okay, so well, I guess the first one we kind of, it's basically the same question, but related to like only one subject over time, right? So like if I experience like a banana right now, and I experience a banana like in 2 hours, how do we think about the informational structures that correspond to the experience of a banana? Must they be the same, or they can be different?
Okay. So about that, then in my reply, so this two neuron system doesn't have any, mechanism in it to know whether something is similar or different, right? Okay. So in this itself, because it's like, lack of the metacognitive module kind of thing. So we can't really talk about that. But from outside point of view, whether the information structure of this guy will remain the same or not, when there is something like learning happen in this system, right? So what we can do, and also, your paper might do is like, let's say, what happens if, in the case of, hypothesizing this guy is dreaming, and we are simulating the dreaming of this two neuron system by making this, input from external environment to be weaker, and then slightly making this self-connection stronger. Okay, then most likely the structure of this, information mix and so on will change to some extent, but this structural relationship will be kept the same. Once we have that kind of structure, similarity structure that mirrors this environmental statistics. Okay, but what is different is that regardless of the input, depending on the state of this system, it completely determines its collier shape. So that's the kind of the difference it will have. But more or less, what I want to say is that when you change the connectivity slightly, there will be a gradual difference in terms of information structure. So unless you have an explicit mechanism to detect the difference, something like that doesn't happen. Like, yeah. Intrasubjectively. Okay, but that's not really, a part of the IIT's theory right now, right? It doesn't have any kind of propose any mechanism to metacognitively distinguish one state to the other. You can build it up at some point, but I don't think we are yet there. That's right. Okay. That's right. And then the next component. Yeah.
Does that actually answer? Is that the question you were asking?
I think it helps in the sense that I can see why you must have like a sort of kind of stricter identity, or kind of, I don't know if the identity is correct word, but why you?
I interpreted your question as like, why should the same mixed structure correspond to the same experience over time? Like, what makes sure that that's the same? So like, you've got a mix that corresponds to a banana at one time point, and you've got a mix for a banana at a second time point. What enforces that those are the same mix or not is what I thought you were asking. But if it's not what you're asking,
yeah, absolutely. That's another aspect. Absolutely.
But that's then it's actually becoming kind of closer to category theory actually.
Yeah, but that's why I thought that's what the question was.
Exactly. So do you want to answer according to your understanding?
You go first.
So my understanding, or this is something that I think I have discussed in the lab meeting before, but many of you guys were not there probably. So same or different is not a really trivial kind of concept. Okay? Everything is, in a sense, different. Like, this part of the table and this part of the table, even if you cannot distinguish, at the moment when, as long as you know that there is a difference, it's different, right? But you are discarding this difference actively to treat it and also abstract it to treat it as the same. But each pixel is very different here, right? Even though you cannot verbalize or label it. So the sameness or similarity is a kind of the very complicated kind of a mechanism that you cognitively or intuitively do. And even the the whiteness here and here, that's also not trivial to compare. That's what Ariel is trying to do, right? With his color similarity judgment. And one way to quantify the sameness or differentness is to characterize the similarity or relationship between this guy to others. Just saying these two things are similar is not enough, because it's so vague in a sense.
You mean the relation with other instances of white or whiteness or other colors?
Everything. So relation to between this to that, this to this to that, or this to even smell, this to sound.
Okay.
And then something here, and the same thing, same kind of relationship you try to characterize. It's more or less the same, right? But there is a huge difference in terms of location.
Yeah.
Location is definitely different. But if you don't consider the location in this category of things, then the relationship becomes almost identical here. But that's because you are discarding one aspect of things here, location.
And we can do the same with time.
Yeah, more or less.
Okay.
Is that more or less satisfactory answer to you or no?
Yeah, I mean, I could go into a lot, but I don't want to. We can, if we've got time later, I'll check that.
Is there anything that others want to say, or Steve, it's fine? Okay, let's go. And then this one, fourth one.
Yeah, that relates to what we have just said.
Okay.
So,
But this is a different issue again.
well, like, so if you want to analyze this relation between informational structure and experience, as we have just said, so do we have a so I think everyone agrees that like an informational structure maps to one experience, okay?
Mm-hmm.
But so why must one experience, does the same experience map to the same informational structure, right?
But okay, so maybe there's a couple of things to also say about that. So let's say mix space and then experience space here. And then there are many things to be said, but in our category theory approach, what we are saying is explicitly that trying to identify something like that directly between this to that, this to that, this to that is hopeless.
Mm.
Okay, so that's what we said explicitly in 2016 paper. Mm. Rather, just let's think about one way of arrows here. And then if there is some kind of lawful mapping, fine, great. And then later or maybe potentially first to project into from one experience to mix. Okay, that's great. And then after establishing both ways of the arrows, then we start to think about further what's the nature of these arrows. Even there, it's still not like one-to-one mapping or isomorphism, which is really strange to think potentially, but yeah, once you get to category theory, probably there are several examples like this. I don't know whether Steve wants to say things. I don't know. He may be muted. Yeah.
I know. Keep going. Maybe I'll say something later if you have a specific question. But
okay, then so our approach is, first of all, if we bring different kind of experience, which is related in some way, which is this arrow within this experience is similarity. Now that you guys are doing lots of experiments, you can imagine what these things are, right? Let's say this arrow is a similar, this is a dissimilar, or something like that. But we can always, as long as we can compare these things, we can have an arrow between any two objects within this experience. Even this with a sound, we have this arrow. Okay, then we go into the brain and then measure the neural activity and the states as a structure and the connectivity, and then we derive this mix for each of this experience. Okay, and then if this is similar, then this has to be similar, and then compare to this one. Okay, and this is still not done properly. And the translation from here to there is likely to be wrong in the current IIT in many ways, probably. But then that's a sort of the chance for us to improve IIT, like, kind of theory, basically.
What do you mean by wrong? Exactly?
Like, on the way they, compute this, mix, or on the way they consider it, axioms, or many ways. There can be many different ways that it goes wrong. Yeah.
So just with the IIT theory, is there any this, if I look at this kind of picture that you've drawn, it looks like there's some bijection, some one-to-one map. Is there any reason to expect that it should be that? Does IIT give any hints that it should be a bijection, or something injective or subjective?
No, so IIT, okay, so this is our approach, but IIT's idea is that the experience and then mix. And if I only read the 2014 paper directly and then don't consider anything else, they consider this is identical, basically.
Right. It's just like some one-to-one mapping.
And it's even not one-to-one mapping. And then sometimes in Andrew's paper, it says that it's not the identity, but it's explanatory identity. So they are considering something like this.
Because I'm just thinking, in the example that you drew above, where you have these two neuron models, right? And you have these two light sources that are. I wasn't quite sure if there's some cause and effect, or if it's influenced by those two external sources.
Only here, only this direction, right?
So I'm just thinking, let's say you had something with a 2 neuron model or a 3 neuron model, but you have multiple experiences that inference information onto those neurons. You can have a much larger space of experiences, but because your toy model is so small, you only have a finite amount of possible MICS configurations, right? So wouldn't that mean, for me, that you should expect the experience space to be greater than the MICS space, so you have some kind of
so that's one of the possibility, right? This one could be bigger than this, or this one could be bigger than this. But once you start to talk about this kind of thing first, then this kind of issue becomes very, very complicated. Which space is bigger and which is embedded, and so I that's one of the reasons why we think that just thinking about one way translation at the time is better. But anyway, so to come back to this issue, so your original question was this one-to-one mapping from mixed to experience. So this is what IIT assumes or proposed, right? And then one-to-many mapping from experience to mix. So you're saying that this to map to different mix.
Yeah. Why is it not the case?
If something like that, and this is not the same, then what does it mean? I actually don't understand that.
It's it's basically what people objected to identity theory. States can be multiply realized, right? It's not said that the pain you're experiencing right now must be realized by the same physical structure of the pain that.
But here, the same is the one that you need to actually think about more carefully, right? Many cases we are talking about same as similar, really.
Okay.
Okay, this is similar or identical to itself only at this moment and at this location.
Right.
You know.
Yeah.
Maybe I am confused, but I would have
Okay.
thought that according to IIT, or at least a theory very similar to IIT, it would be impossible to have a one-to-many mapping from experience to mix. And that in fact, if you found a one-to-many mapping from experience to mix, IIT would say, oh,
Yeah.
our mix is wrong. We
Yeah.
have to change that such that there is a one-to-one mapping.
Exactly.
Okay. So this kind of forced by the strongest thesis, right?
But this is also, I think, you know, in a sense, it's really likely to be impossible to test empirically. I'll just say because this, you know, one experience to go into slightly two different, you know, mix. You need to have really absolute, you know, control of exactly this experience. You know, what we can do is like similar experience of this space, right?
Okay.
But I'm just to push the point, the idea would be if you could somehow be sure that you were repeating the same experience and yet you found like multiple different mix that corresponded to that.
Yeah.
I think that IIT and Julia would say we must have the wrong conception of what mix is, because the fundamental assertion of IIT is that there's an identity between the structure and the experience.
Yeah.
So what you really can test experimentally is not the relation between the informational structure and the experience, but the relation between the two experiences and two informational structure. And
By that structure, what we are talking about, this mapping, right? So because of this and because of this kind of thing, I think it's really, you know, not really useful or, you know, hopeful to think about this kind of one-to-one element mapping. That's you know, fated. Make sense? Did you guys want to say something?
I was just asking Angus about the top assumption, you know, like I was asking, does that mean then that if you have some MICS snapshot, you can tell exactly, would that imply then you can tell exactly what they're experiencing?
Sorry, I just want to revise my answer.
Okay.
And I was just thinking like, yeah, like personally, like I don't have, you know, any experiment that's back this up. You guys probably know what's the idea. But for me, I think it would be intuitive that if I took a snapshot of some kind of structure, I probably wouldn't be able to tell which experience exactly that corresponded to, just from what I would expect, right? If there is some information that's being encoded within like some lower kind of dimensional space, which could be, you know, your 3 neurons or however many neurons, then should.
So now you're asking about different kind of one-to-many, right? So it's more to do with the other way, like this particular mix to project to these two experiences.
That's what I would.
And then Angus's answer is?
I can do the above.
Well, at first, so because I was like listening to two things at the same time, at first I didn't hear that part of the question I heard at the end. And that's something I said we should ask now. But the first question I heard was, if you have that one-to-one mapping, does that mean if we have a snapshot of the brain, can we like read someone else's, get their experience just from the snapshot of the brain? And I said yes at the time, but I revised it to no, because the thing that's missing is those relationships between the structures. You need to know how that structure relates to everything else.
So sorry, so you're talking about like so in that top thing, like the structure in the causal structure in the between the neurons?
No, so like in the top one, you just have a one-to-one mapping. But what's missing is you don't know how like each of the experiences relate to each other.
Right. Okay.
And without that, those sets of relationships, you don't know what the experience actually is.
Okay.
And that's why you have all this arrows
Within
the bottom.
Gotcha.
No, I don't know. I probably disagree with you about that. But you know, let me develop. So the brain contains a huge number of neurons and a huge number of synapses and so on, right? the connection patterns and so on. It's really homogeneous structure, and then I think including all these background condition, there is this structure that determines the meaning or similarity pattern of all these things embedded in terms of the structure and activity states in that particular moment. And that defines all the possible relationship between all possible experiences.
I don't think you guys are necessarily disagreeing. I think
Yeah,
this is just asking for an enriched, like it's the mix plus the other stuff that's there.
maybe, but maybe to clarify more, what I'm saying is that all the connections and also property of the neurons inside of this complex in IIT is already sufficient to unpack everything, including this structural difference between the possible experiences within this thing. And that's why, once we, decide this architecture and the states of this two neuron system, we can already estimate all the possible experience of these neurons and its similarity rating.
Yeah, so yeah, I think what I agree with Ariel in that. So basically, I was just constraining to if you only know one state and nothing else, then you can't know what that mix is actually mean. You need to have that extra context.
I see. So just knowing the structural connectivity, but is it? So you also are saying that not only this information, but we also need to know this state of causal structure TPM and then the other state and things like that, or
We need to find how it relates to other states.
then I don't know. From IID sense or category theoretical sense?
I don't know which one to put it in, but
But anyway, maybe we don't get to the answer about this, but let's move back to Rob's original question, right? Can this be possible? And if IIT is correct, and if then what IIT is claiming is this is impossible. Once we know exact mix, then we know exact experience. That's my understanding.
And not a neuroscientist, like extrapolation here, does that kind of correspond to like you can mind read then? Like if you
Yeah, but mind reading is actually easier than here actually, because it's a much more sort of surface kind of thing. Getting here is much more difficult fundamentally. And then you wanted to say something? You didn't just understand what I said here.
I didn't understand what you're talking about there.
So what I said was that the IIT is all about structural connectivity of the things here. So once you know what kind of element this guy is, like this one fires when it receives more than one input, and also this guy is connected out to this one, and this one is connected to this, things like that. Then all these transition probability matrix that describes how this thing actually changes over time. And from this, we can construct this, Angus's, kind of shape of this, causal relationship as a graph. And then this corresponds to one particular experience. And what I said was that this connectivity structure of the core of our experience is the only thing that determines everything. It unfolds all the necessary things that to understand this guy's memory and the disposition of planning and everything. It's all encoded in the synaptic strengths and physical mechanism at one time.
At one time. So you only need to know you only need to one snapshot of it, and then you know how it works entirely.
Yeah, in a sense.
That would be the same assertion as like if you have an experience in any time slice,
Mhm.
then you need all of that information, and then you have that person's experience in that time slice. But it would mean if that were not the case, it would mean you couldn't have an experience like in just one slice of time. You'd have to integrate over some larger period of time for speaking about an individual experience to make sense. At least that's how I conceptualize it. Whereas this says like it makes sense to think of experiences in one slice of time corresponding to one slice of neural information.
Okay, so you're not inferring from one time slice to all time slices, right? You're not like, okay, so I see how the brain works at this particular time point, and I know it's how it's gonna work, in other times.
Empirically, how you can actually make that kind of prediction is a totally separate kind of question, okay? Because there are lots of, physicists would have lots of things to say, like chaos theory and also, fluctuation at the level of quantum, thing which is completely random in theory can propagate up to, macro level over the time and so on. So it may not be completely deterministic, but in principle, this is what IIT is implying. All of your experience, past and also future planning is embedded in one shot of this structure.
Okay.
But where does it come from if it's not? You think that the memory is somewhere
Wow.
else?
Yeah. Interesting.
Okay. Fine. So both of this many to one to many is basically, prohibited, and many to one is prohibited according to directive.
Right.
Okay.
Right.
And then structure preserving is all about this kind of relationship to map to another one. I'm not sure whether you get it. So IIT actually didn't speak about the relationship here, right?
Right.
But that this is, I think, more important thing. And Andrew Horn's paper is trying to start to talk about the relationship. And then this is the last part of your slide.
Yeah. Well, the first one we just answered. So I guess it's an events type of mapping. And then the last one is something about how we construct the experience domain, right? So like how, for example, how do we define a similarity between an experience of thinking 2 + 2 = 4 and seeing green? Is that more similar to seeing green or to feeling anxious? And we can go on. Or is it more similar to feeling pain or seeing?
First, I don't understand what you mean by types here.
Types are categories, are like are universal. The events are particular.
Is it like when you define some kind of range of the similarity that you define, this serves as a kind of that types that you're talking about?
Yeah.
Okay, but that's different from what category theory talks about as a category. Okay.
Yeah. Okay.
Just to make sure.
Sorry.
Can I open the door?
Yeah, I'm also getting.
Is types like determinables and determinants?
Something like the redness, right, is a type, like different instances of red are particular, right? So, but as far as I understand here, we are concerned with some sort of like particular experiences, right? A particular experience at the time is identical to a particular informational structure at the time, and we're interested in then finding similarities between events and similarities between informational events, right?
Yes and no. Why I say this? So by qualia, many people actually use it in different ways, and then we talked about this in some papers. But this broad sense qualia and also narrow sense qualia is something useful to distinguish. So broad sense qualia is the kind of thing that, the thing that I'm experiencing now entirely. It's a kind of snapshot that we talked about. At the moment, including everything. That's the broad sense qualia now. And the narrow sense qualia is that, among this, one part of the thing that we can focus on, like, this particular block is similar to this particular block or something like that. This is narrow sense qualia.
Yeah, but
It's embedded in this. Okay, and then?
yeah, but we can do the same, like we can do the same type of distinction between events and types, even for narrow and broad qualia, right? Like,
But by types, is this the correct description of what you mean by types? Some kind of,
a type is like, for example, feeling pain now, feeling pain in 2 hours, feeling pain in 4 hours. What makes those experiences similar? What lump together the experiences? The painfulness.
okay,
The painfulness is the type,
okay.
right? Like the fact that it happens at a particular time, those are particular events.
Is this like a metacognitive thing that you are aware of similarities between qualias?
And you don't need to be aware. You don't need to be aware. It's just like a metaphysical thing, if you want. It's like
So you're just talking about a narrow sense quality.
well, it depends. If for broad sense, we mean like the qualia as in like with the spatial temporal properties, I guess, yes. But we can have, I guess, a global state, including like visual experiences, tactile, sense of smell, whatever you want, and do not include the spatial temporal dimensions. And you can replicate that at different times, right? So in that case, you would have a global states that are events. It depends how we define the global states or broad qual.
Well, yeah, but let me read what you're saying here. So, and it's a mapping between types of experience and types of mix. So if I understand like this way, like there's a range of the experience that you consider or somebody label it as a sort of the types, same
Okay.
types of experience that has to map onto the same types of the mix.
Right, right.
Is that what you're saying?
That's my question. Yeah, is it the type of mapping between mics and experience is between types or between the each singular?
Yeah, so I think this is reasonable kind of, hypothesis actually in this way, both this way and then this way as well. Because of the practical difficulty in defining one single experience, right? Like when we are showing this in red dot in here and then here, we are kind of assuming that they are similar, and then our experiment seems to suggest that they are really indistinguishable in terms of structural difference and so on. And then mix-wise, in terms of broad sense, it's definitely impossible to compare, but by looking at the particular brain areas and the particular part of the mix, which corresponds to our color experience, we may have something that range of the shape, like let's say this shape and this shape and this shape, all of these are associated with the red. So that corresponds to this range of the mix corresponding to this range of the experience.
Okay.
I think this is a reasonable thing. And then events wise, particular informational events. Informational events correspond to this one. Why do you distinguish types and the events?
The event would be the specific experience.
This one.
Yeah, exactly. Yeah, that one. But like,
okay,
I guess what makes more sense, like from the perspective of the category theory project, finding a mapping between events or types. So
I mean, events are definitely potentially, the most appropriate thing to get to eventually, but practically difficult. So I don't think we should start from there.
okay, that's useful. That's useful.
But theoretically, if you want to make some kind of claim, I'm fine with either.
Okay.
Okay, and then the last one is,
Yeah, the last one is how we define the experience domain. So
Okay.
how do we find similarity between experiences? Like,
it's according to you, up to you. If you don't feel like, 2 + 2 + 4 is similar to green, then that's how you experience things, right? Maybe your brain is configured to perceive these things as similar.
okay,
And that means that, mix wise, your shape of the 2 + 2 = 4 and the green is almost, this kind of shape. For me, it's very different. This is my 2 + 2 + 4, and then this is green, probably. Because I feel they are very different.
but doesn't this conflict with the real goal of category theory, namely that we have some sort of reliability in the structure of experience and structure of information such that we can go backwards, and once you study an informational structure of another subject, then you can infer something about its experience. Is it?
But what I'm saying that, if you, Niccolo experience feel, this 2 + 2 + 4 is similar to green,
Yeah.
then that means that, you have a brain and the structure that somehow make this 2 + 2 and also the green qualia to be very similar. But that's probably because your brain is configured in that way.
Right, but the question is, now you study someone else's brain,
Yeah.
and you see that there is the same relation that I have between 2 + 2 = 4 and green, but in the other subject.
So that's a practical or more empirically believable kind of situation, right? Almost everybody, I can imagine in humans, 2 + 2 and the green and what else? That anxious are all separated really clearly. Everybody, pretty much, everybody we can test in a reasonable amount of time. I think nobody will confuse these 3 things, and therefore that corresponds to the mix or brain state is probably very distinct as well.
Yeah, but the point is that in principle, it's possible to have different, as you said, it depends on the subject, right?
Right.
So in principle, it's possible that different subjects categorize the similarities between experience in different ways.
Yeah.
Are we able to get report from them if, right? We can get report from them, right? If they can report that they feel 2 + 2 is the same as green, and it's already evident in their response.
I mean,
Verbal report, behavioral report.
we don't need to go this kind of extreme actually.
Yeah.
Thinking about some subject we talked about today, right? Who doesn't have a one type of the cone, long cone and medium cone and short cone in the retina. And there are cases where some people actually don't have one type of cone, and then grown up with us, and then when they are shown like 93 patches of the color, and then they name each of them, the pattern of the naming is almost the same as us, basically, in their case. And my hypothesis is that even though at the level of the retina, they are quite different from us. Once it comes to the brain, and then comes to the part that generating our color experience, they are probably more or less similar. And depending on how you probe it, they probably produce the same kind of mixed structure and also experience. That's one possibility. So and reverse kind of thing can be expected for the synesthetic subjects, right? Input wise, it's identical to us more or less, but because there is some kind of excess connection within the color area to digit area, we never feel like 2 and green is similar, but these people will feel similar, and that's supported by the mix, this part of the mix to be similar. But in the sense of the narrow qualia, okay.
Okay, but okay. So if you don't know that a patient that you are studying is a synesthetic one, and that patient tells you that the experience that is undergoing right now is similar to thinking that 2 + 2 = 4, you might infer that the experience is like a sort of thinking of arithmetic operations, right? How do you go from the informational level to the fact that that subject is actually experiencing
So
dream, for example?
that's what I mean by this single snapshot of the brain is sufficient to predict for both experience and this thing, right? Because if we have a synesthete's brain, then unfolding their brains, on mix to arrive at, okay, so based on this brain architecture, this person should perceive 2 and then green to be similar. And that makes a prediction about the similarity, and then we can ask them. That's one way of doing it. And the other way of doing it is coming from this side, like asking them to do a lot of similarity rating tasks and so on. And then this has been happening in the history of science, right? Based on the relationship that they are making some kind of statement, we infer that, oh, this subject must be synesthetes. And then when we look at the brain, oh yes, in fact, this guy's brain is generating similar pattern of activity when they see 2 or green. So it's both ways are possible. But going from brain to experience, this direction is much more difficult compared to these 2 directions.
Right. I think I
Makes sense?
Process that. it's more with the scope, my problem. So like you might think of animals who cannot report, right?
I mean, I think they can to some extent, and that's also part of this Yoneda lemma kind of approach. And many of the animal researchers have been doing it. For example, I talked this idea with animal researcher who studied peer conditioning. Okay, that's so. No animal researchers conclude that okay, if you present electrical shock, yeah, you would be the best person, but and then mouse start to freeze, when they hear a particular tone, right? And then you conclude that, oh, okay, so this mouse is experiencing fear. Just by the single experiment. They never do it. They are much more careful. And then one possibility is like, after hearing the tone, they just become like, incapable of moving only, not related to the fear at all, right? If that's the case, then you wouldn't expect that cortisol or some kind of stress hormone to increase or anything like that. And then that's something that you also consider as a one particular relations between fear and the bodily state and so on. And mice's fear and our fears are, in terms of relation structure, more or less, same. That's what they are trying to establish. And then when they can establish it, then we can consider, okay, mouse's fear is very similar to our fear with some limit. We don't need a verbal description, a verbal report for everything to get their experience, I think. That's also one of the implications of the Yoneda lemma.
That's it.
Make sense? Yeah. Okay.
Can I explain?
Yeah.
You mentioned this aspect of experience that with the 2 pens, that if you take out the location, then the experience collapses. So when you were holding the 2 white pens. So if these experiences the same if you take out, for example, the location, right?
Yeah.
Would you be able to do that with mixes as well?
Well, so that's a conjecture. So the conjecture is that, if we construct the phobia, neurons and so on, that, generates this experience of the phobia, this shape corresponding to this shape and, peripheral, thing, this shape is the same or more topologically, indistinguishable. And that's the reason why we report this white and this white to be similar.
But so then the mix would be also similar.
Yeah, mix should be similar, partly. But when you embed it in whole of the experience, it is, and this part is embedded in everything to have this space of phobia, right? And this one is having this particular experience to the right and then here. So that in that sense, it's different. Something like you can imagine this as this is my imagination, but let's say you have this kind of shape, and then here locally you have this. That's a phobia, and then here almost the same kind of shape, very. But it belongs to one shape of seeing one thing, and then there should be something here. That says that all this and this is same. That's also part of this shape. Make sense? Is there anything else to talk about? Maybe
I have a question on that last point. So I read that as how we find how we get similarity between different modalities.
Right.
So like say you might say the difference between 2 + 2 = 4 and green is just so big that you can't distinguish it between the distance between 2 + 2 = 4 and feeling anxious. So in terms of getting the mix and kind of matching all the arrows and relationships, would that mean that there are some things which you just can't get arrows between or which aren't important? Like, for example, vision will have all the possible relationships between all the visual experience that you have, but then there's just one big arrow going to cognitive thought, and there's no really any distinguishing any arrows or something you can distinguish between this group and this group, which are from different.
That's a really great question, and so far we have been always thinking about similarity as one type of arrow, right? And then we have eight arrows in a sense, with our similarity rating, because we have a different, similarity rating corresponding to different types of arrow. But similarly, we can consider that one type of arrow, let's say, we draw by black, corresponding to modality is different. Modality is different, exists only here. And then red is feels similar, let's say. And then this is only here, let's say. Then this is corresponding to the situation where this and this is potentially like auditory experience. And these two things are visual. And then there could be another visual experience. But this one there is no red arrow here, meaning that it is within the same modality, but it doesn't feel like same. Make sense? So, we haven't done any of the psychophysics experiment, but, eventually we want to have multiple arrows between two object kind of experiment. And that's what we kind of talked about with the flowers.
Yeah.
Flower-wise, we can have multidimensional kind of questions, right? Let's say if you have two flowers, you can rate the overall similarity, color similarity, and also preference. Which one is preferred? It's all natural kind of question. And most likely that kind of, multiple relations among multiple objects are probably unique to each of the modalities.
Yeah, I have a question.
Yeah.
How is it different between mix? So you consider different types of like red, black,
Right.
and that means we should have brown.
That's a good point. Yeah, maybe this is another kind of conjecture, but yeah, within modality arrow could be similar in the distance between this kind of shape. Maybe, I don't know. It's difficult question. And then the different modality arrow could correspond to something like here. at the very beginning of the structure, it's already different.
I do have a question.
Yeah.
So here, do you mean cross modalities? There's like one big arrow from one modality to the other. Is it possible that some visual experiences are more closely associated with some auditory experiences than the others?
Yeah, bro. If that person experiences that way, yes, right.
Yes, I think it's very possible because some music might sound darker.
I but want to see the empirical evidence for that actually, except for the, synesthesia. I'm not sure whether people actually have measured the similarity rating between, let's say, very loud noise and very bright, stimulus, and then ask them to report the similarity.
I think that this could be.
But
it would
do you
be
rate some kind of two modalities as similar ever?
I think here the definition of similarity will become very ambiguous.
Yeah, we need to probably instruct people.
You can write the disturbance. The disturbance might do the same.
Disturbance.
If
Yeah, so that's another possible arrow actually. Even if you know that this is very different modality, you can find a commonality, right? Like a disturbance wise or something like that. And then if there is many arrows that relates to that points to the similarity in one sense. And then if you have that kind of arrows, then eventually this and this becomes similar in experience. That's also related to Yoneda's lemma in a sense. Two objects that out of possible, let's say 1,000 relationship, 990 is shared, then these two things are likely to be extremely similar. Something like that. Okay. I don't know. Maybe Steve, do you want to say things? Because we discussed quite a bit within us. So, but now that we have you, we can ask your opinion, thoughts.
Yeah, well, there seem to be, I guess, lots of discussion about similarity and equalities. I mean, one perspective is just to look at, in like the category theory perspective, you can weaken the notion of equality to be something like equivalence.
Yes.
Some of the discussions seem to be around those lines.
Exactly. Yeah.
Someone mentioned something about types, and the general thing is called quotient. So you can take one big thing and reduce it down by looking at its equivalence classes. And you mentioned earlier that deciding when two things are the same or not is very difficult. In some sense, everything is different. But in some, I mean, for example, if you can define some sort of equivalence relation, and then you can look at the classes or the representatives of those classes as your notion of identity. So every member within the equivalence class is actually not identical, but from the perspective of its the equivalence classes. So you have two levels of identity there. One is the identity of the individual members, and then one is the identity of the classes those members belong to, the equivalence classes that those members belong to. So that's a kind of weakening that could be useful, I think, from the discussion that you're talking about, the relationship between experience. I think you said that IIT says that there's a strict correspondence between experience and the mix. Is that what you call it?
Yeah. So what I tried to sort of dumb down what Steve was trying to say is that let's say, I don't know, maybe Steve, you can tell me, tell us whether my example is wrong or not. But let's say if you have a natural number, and then you have like -11 to 0 to I don't know, this is an integer, and then up to like 100 or something like that. And then if you can distinguish all different members as such, but you can also consider equivalence class by two types, where you can divide by two exactly and without any remainder and so on. So something that regards similar to 0 and then 1. It's kind of binarization. And then same kind of thing, but colored in a different way to be either sort of the same structure versus different structure as this kind of category, where you distinguish just only two things. This itself is not the same or equivalent to integer itself, but when you take this perspective, then it can be regarded as equivalent.
Yeah. Yeah. So there are various ways of weakening the notion of identity. So in principle, in theory, it's not such an issue, but you've got to state up front. What is it that you're taking? So in category theory, you usually take, say, isomorphisms as a notion of equality. So that they're not identically the same, but there is some isomorphic relationship. Well, you can have other ways of weakening it as well. And it seemed to be that a lot of the discussion about whether that's true in consciousness, qualia, and so forth. Well, it could or could not be, but so from the category theory perspective, you're not forced to say isomorphism, equality up to isomorphism, for example. That was the point of my response to Niccolo's question. There are various ways of weakening it.
So maybe I'll just point out that there are lots of terms that are very complicated, right? And these are all different things actually within the category theory.
Yeah. So the nice thing about category theory, it shows you how they relate in a sort of very precise, formal way. But it doesn't tell you, it doesn't dictate which one you use. Of course, that's up to the application, how it aligns with what you're studying. And they're just some ways, like the notion of equivalence is another way.
The equivalence is not in here actually, but that's another type of similarity. And the equivalence also has a different level, right? Categorical equivalence and also.
Yeah.
Yeah.
And you can define, for example, even something as simple as a surjective function, you can define an equivalence relationship over it just by simply pointing out, identifying all those inputs that map to the same output. Well, that itself defines an equivalence relationship. And then once you've done that, then you can say, okay, all these different inputs, they're identically not the same, but they are the same up to the equivalence given by what they map to. So in that sense, you have sort of something that's, I mean, you got to be careful with equivalence. I mean, you can just define, I mean, an equivalence class is based on the equivalence relationship. And so you could just say, okay, let me just define any sort of equivalence relationship, and then it gets really arbitrary. But you have to have some criteria for equivalence. And in the case of the surjective function, the map of the inputs to the outputs gives you your criteria for when two inputs are the same up to that equivalence. So it's one way to address that issue. So presumably something similar would happen in the case of consciousness and qualia. Two things are the same because, well, for most of the time, you treat them the same with respect to certain actions that you do in those situations. So that would be another way of looking at weakening the notion of identity. It's a sort of task-dependent criterion in that case because
so the task dependence is kind of related to this. Looking at the same thing in a different kind of way, right? Different kind of in a sense.
Yeah, so getting back to your point about having multiple types of similarity between two things.
Right.
Presumably an experimental paradigm, you could prime one or the other depending on what you expect, what the subject expects to be able to do. Like you could have similarity based on loudness. Well, if the task is to distinguish whether two things are the same loudness or not, that would prime one kind of equivalence relationship based on the the demand of the demand of the task. And then if you change the task to another kind of, say, color or tone of the music, that would prime another kind of similarity or relationship. In fact, they don't all have to be in the same space. I mean, you can look at different metric spaces or similarity spaces and have maps between the two. So, I mean, there's within a particular context or a particular space, there's only one map between one relationship, but you can transform that with what's called changing the base or changing the metric space to look at a different kind. So in total, there could be lots of little similarity relationships, but they can be all contextualized and separated out by regarding them as different metric spaces and look at the maps between the metric spaces. Yeah, so lots of possibilities.
Yeah. Okay. So.
And one other point.
Yep.
Somewhere back in one of your previous slides was a question about structure, preserving structure. I think it was Niccolo's third or fourth slide. Does it have to preserve structure or something? I forget exactly what the question was, but yeah, that might be it. Let me just see if I forget. So that even in category theory, there are lots of ways. There's lots of notions of structure preserving, or lack of structure preserving. And the common one is what's called the underlying functor or the forgetful functor, which basically strips off certain relations, but not all of them. So, for example, if you had let's say if you had a category of groups, for example, and then
groups,
so each object is a group, and there are maps between the groups, which you kind of think of kind of similarity relationship between the groups. And the forgetful functor will take each group to its underlying set. And so basically that's stripping off all the group structure. So that's sort of the maximal way of doing it. But you can do it stepwise. Say groups are special kinds of monoids. And so you can just strip off the inverse relations in the groups and just maintain the rest of the information, which is a monoid. And then you can strip off that monoidal information and then go to the set, so that you can see that there's a sort of gradation there of losing, preserving structure.
Like this, right?
Yeah, I can't really see it clearly, but basically you have three categories. One category is for groups, one category for monoids, and one category for sets. And then the forgetful functor from groups to monoids, and then from monoids to sets. So that top area that you got is the direct one from groups to sets, and then so you can keep that, and then you have arrows from group to the monoids, and then from the monoids to the sets. So it's another way.
Yeah. So in this case, both element here, object, can be mapped into this, right? And also these relations also map onto these relations.
Yeah.
There is this mapping or functor mapping here, and that's a structure preserving mapping. But from here to here, there is nothing like that, because this, relation disappears. No?
Well, that's possible, but in general, there are two functors actually. One's called the forgetful functor.
That's true. Sorry. So if we consider this kind of mapping, that's a functor, right?
Yeah. And then there's another functor going in the other direction called the free functor, which takes your set to the free group on that set. So
but just to explain this example. So why this is possible is that all of these relations, both this and then this is mapped into now here.
Yeah.
And then this object goes here, this goes to here, this goes to here. All these things has an mapped onto here. So this is a structure preserving functor.
Yeah.
But this is very different from what you're thinking as a structure preserving mapping, right? But this is. But that's a richness of the category theory.
Yeah. And so you don't have to get rid of all the structure at once. It was the point I was trying to make, is you can do it if you were to map the groups down to the monoids, you're losing the notion of invertibility in the group, the inverse, but you preserve the other aspects of the group, and then you can go from monoid to sets and remove the mod order structure as well. And you go the other direction as well.
Yeah.
The general point I was just trying to make is that, yeah, there are even within category theory, you don't have to preserve everything. You don't have to forget everything. There's gradations, but of course that'll depend on what sort of category that you're working with.
Yeah, so basically the point is that there are lots of ways to structure preserve.
Yeah.
And what I suggested in this 2016 paper is that starting from this weakest notion of function in both ways, one at a time is the better way to think about making progress rather than directly going to this kind of isomorphism or identity.
Yeah, sure.
Which has been successful in mathematics and other fields. To add more. Is there anything else?
So,
yep.
Not really. Just expand on that. Like in cognitive science, notion of one-to-one correspondence is pretty ingrained.
Yeah.
So people either you do it or you don't. But like in category theory, getting back to the two functors, I was going to lead up to is in the adjoint relationship. So what I was going to get up to also say is that this notion of weakening, there's another way of weakening it, and that is with the adjoint relationship. So which relates to the Unetta thing. And someone else asked a question about whether one space is bigger than the other. And this is probably what I was saying in my response to your question last night.
Yeah.
So even in the Unetta case, and in the adjoint situation, is that you have bijections between the Hom sets. That means the maps between the objects in the category.
Very difficult for you guys, probably. Something like this, right?
Yeah. So what I wanted to say is that you have two levels. Well, one of the nice things about category theory is it really keeps track of the levels at which you're talking about. So sometimes, generally we say we have a category of objects, but the objects themselves can be categories as well. And so you want to keep track of whether you're talking about, what level you're talking about. So in the Unetta lemma case and the adjoint relationship case. So what the general point I wanted to make is that in cognitive science, we really talk at just one level. That's why a lot of these discussions get rather confusing because they don't specify what the context is, what level they're really talking about. And now, in the adjoint situation, we're talking about a one-to-one correspondence between the maps, but not a one-to-one correspondence between the categories. And so in the Unetta case, one of the categories embeds in the other category. But so the answer to that question is one space bigger than the other. Well, Unetta, in the general situation with the Unetta lemma, yeah, that's right. The base category C gets embedded into a larger category. But the embedding is very special in that it preserves the Hom sets, but there could be more Hom sets in the larger category. So once you have these notions of level sorted out, then these finer distinctions between identity versus similar equivalence and so forth make a lot more sense. And they seem to go round and round circles all the time, like they seem to do in cognitive science.
So this is also another thing that I want to introduce at some point with the empirical experiments or some kind of concept. This is going to be probably another theoretical paper. Maybe with Steve, and Hayato, we are trying to get to that. But what basically this tries to say is that when there's two categorical things or two kind of conceptual things, they do not map exactly one-to-one. Okay, something like a real number and integer is one case that you can think of. Like if you consider considering the operation rounding, right, or seeding or flooring of the real number, 3.1 gets to 3, right, and then 3 goes to 3.0 in a real number. Let's say here this real number to integer thing is not really one-to-one mapping, right? at all. But there is some kind of mapping that goes from here to here and here. It's sufficiently close. Something like this situation. And this is a kind of situation that is much more important and useful in the real life, and also, you know, theoretically also important, even in mathematics. And I think one example here would be like attention, with or without attention. I think that can be potentially a case of the adjunction. You know, if we don't pay attention to something, then we lose some stuff. But comparison between attended versus unattended is not going to be completely random. You know, we have some kind of category, and also we do see something, and then it can come back to, you know, where you started with. So, but I don't know. I don't have empirical evidence to say that, you know, attended versus unattended is adjunctive relations, but that's intuitively I feel it's probably correct. Right?
Yeah, one of the reasons, one of the ways to think about it is that the adjoint situation is sort of a local bijection, local in the sense it's localized to the specific Hom sets, but not globally isomorphic, as in the integer real example.
Yeah.
So that makes sense intuitively from a psychophysics perspective in terms of attention. So attention is a local thing.
Right.
So you can think, okay, what you're attending to is structurally consistent, but it may not be globally consistent with the rest of the domain that you're looking at.
So locally, like, you know, a real number of 3 exactly is bijective to integer, right? So it's a locally. And that, you know,
so in that case, the relationship is between the local relationship is between local relations. So in the real numbers, you take the real numbers, like the integers, are ordered, and so it's the order relationships between the real numbers and the integers that are in one-to-one correspond as well. It have to be, because there's only one order relationship between any two numbers.
Yeah, it's kind of
but the sets themselves are not in bijective correspondence by the usual idea.
This is all, you know.
So that's why it gets a bit tricky, I think, is because there are several things going on at the same time. Whereas typically in cognitive science and cognitive modeling, we just say, all right, let's just take this one level and just do it that way. But that's where the problems start to crop up. If you've got some never-ending dispute in psychology, it's probably because there's a levels issue floating around and people try to push 2 levels together when they shouldn't be. The nice thing about category theory, it keeps those levels distinct and their relationships intact. So that's why, for example, in the integer, it seems counterintuitive, but why should there be a systematic relationship between the integers and the reals when you know that the 2 sets are not the same size? That's because you're really talking about 2 different kinds of relationships there. One is between the numbers themselves, and the other is between the relationships between the numbers. And that's the relationships between the numbers that are locally consistent, even though the relationship between the sets of numbers is not.
Okay. We probably need to, it's probably fine. We can still go a bit further, but Steve, do you have anything else to say?
Oh, no, I think sounds pretty cool.
Yeah, that's great. Okay. So then we'll probably end at this point, and then we thank both Niccolo and also Steve. Thank you. Okay, thank you, Steve.
Okay, I'm going to head off now.
Yeah, see you.
See you. Bye.
Bye-bye.